Thank you for watching my video. My name is Mr. Charles. In this video tutorial, we are going to discuss difference between photo-darlington and photo-transistor optocoupler. The basic Darlinton optocoupler is formed by taking the emitter of the input transistor and connecting it to the base of the second, and then connecting both connectors together. The transistor, it could be PNP or NPN. Photo Darlington transistor image. Here we have NPN, here we have PNP. This is NPN. NPN has an arrow pointing down here, while PNP has an arrow going backward here. So that is the difference. If you use this arrow to differentiate the NPN and PNP. Now, this is the internal structure of photo-darlington transistor optocoupler. This is the internal structure. Now, let me explain a little bit. Here, now this dot signifies where you will start counting in case if you will see the optocoupler 6 leg or 4 leg. This dot signifies this is where number 1 they start from. Here is number 1, number 2, number 3, number 4, 5, and 6. This number 1 is anode. This number 2 is cathode. This number 3 is no connection. Number 4 is emitter. Number 5 is connector. Number 6 is base. Now let me explain how it works. In this pin 6, in this 6 pin here, pin 1 will collect the voltage or the current from the source, while this pin 2 is connected to ground. Is connected to ground. If there is any excessive voltage from pin 1, it will neutralize it. Now this pin 3, it has no connection. It's just like that. Now in that case, once this diode has finished doing his own job, it will transfer. That is why you are seeing this arrow. This arrow signifies when the diode has finished its own job. It will transfer the signal straight to these light sensors. Now, in this light sensor, we have emitter, we have connector, we have base. Now, this base is the control of these sensors here. This base controls everything in this area. Now, in that case, pin 5 here being connector is signal 1. That is the signal 1 in this area. This connector is signal 1, while this emitter is signal 2. I repeat, in this area, here is no connection. Here is connected to ground. Pin 2 is connected to ground. Pin 3, it has no connection. This pin 6 controls the light sensor, everything here. What it does is, if there is an excessive voltage, if there is an excessive voltage from this place, this will neutralize or it will stabilize the excessive voltage, or if there is an low voltage, it will try as much as to trigger it to make it up to the normal voltage that is required. That is why it's here being the base. Now, this particular emitter is the signal 1, while this emitter is signal 2, sorry, while the connector is signal 1. That is what I mean by that. So let's go to pin 4. In this pin 4, the same thing is applied, but it's a different thing altogether here. This pin 1, it collects the voltage or the current from the source, while this cathode, being pin 2, is connected to ground to neutralize if there is any excessive voltage or current coming from the source, being pin 1. Now, after this diode might have finished its own job, it will send the signal to these light sensors. And these light sensors over here, the emitter being the pin 3 is the emitter. The pin 3 is the emitter, that is the output. Here, this pin 3 is the output aspect of it, while this pin 4 is the ground, being the connector. Try to understand it very well. This pin 3 being the emitter is the output. This pin 4 here is the connector, being the ground, is connected to ground to neutralize if there is an excessive voltage from this light sensor. It will be doing the job of pin 6 here, being here in this area now. The work of this 4, since it's connected to ground, it will be doing the job of base here. So that is how this pin 4 work in this area. Now, this discretion photo-darlington optocoupler, these are the series. These series are the one that I know for now. You can also go out there to find other series. It has 4N29, 4N30, 4N31, 4N32, and so on and so forth. It also has H21B, H21B1, H21B2, H21B3, and so on and so forth. These are the few examples that I can be able to find in terms of photo-darlington optocoupler. It has a high voltage difference between the overall base and connector. That is from the base of the input transistor to the emitter of the output transistor. This is true of the photo-darlington for when the base connection may have a bias added to it. Now, what they are trying to do here is they are trying to let you know that between the base and the connector, there is higher voltage. Between this connector and base, here is between this emitter and base, there is higher voltage in terms of feet. So why is it like that? Is if there is a bias is added to it, so it has a higher voltage in between these two areas, emitter to base or base to emitter. This means that for a typical silicon device, the overall emitter voltage required to turn the Darlington pair on is 2 times, which means for that emitter voltage required to turn the Darlington pair, it means that it will be 0.7 multiplied by 0.7, that it will give 1.4 volts. The saturation voltage of this Darlington configuration is about 0.7 volts, and this may have an impact when the photo-Darlington transistor is used in switching application. In this case, what they are trying to explain is there is difference between double transistor and single transistor. In double transistor, it required the emitter to turn the Darlington pair 0.7 2 times so that it can be able to trigger it, which once it has multiplied, it means it's giving us 1.4 volts. That is what they mean here. Now, it is necessary to be aware that the Darlington pair is not as fast as single. That is the disadvantage aspect of it. It's not as fast as single. This is because the first transistor cannot actively shut off the base current of the second transistor. In turn, this makes the overall device or circuit configuration slow to reduce the current flow or switched off. The photo-darlington transistor provides a much higher degree of sensitivity when compared to other phototransistors. But this is at the expense of response time and frequency response. Now let's go straight to phototransistor optocoupler. In phototransistor optocoupler, it also has PNP as well as NPN, which I have showed you before. Now, this is the structure of internal structure of 4 legs. The same thing applied here, 6 legs. But the difference is here, there is no double transistor. This one is faster. The single transistor is faster than the double transistor, which means the phototransistor optocoupler is faster than the photo-darlington optocoupler in terms of this. Here it has single transistor, the same thing, there is no difference, just as I explained from the initial aspect of it. Now let me use this to explain this a little bit. Phototransistor can be further of 2 types depending on the output pin availability. On the second image on the left, there is additional pin out, which is internally connected with transistor base. This pin 6 is used to control the sensitivity of phototransistor. I have already explained this before from the photo-darlington optocoupler. I have already explained this before. Maybe let me throw more light on that. Now, in this area, this number 1 is anode, number 2 is cathode. Here, I don't think that it has number 3. There is no sign or area of space of 3 here. What I saw here is 1, 2, 4, 5, and 6. Now, what happens here is, since there is no 3 here, now this number 1 here, we collect the voltage. Here is the cathode, which is connected to ground. Now in this area, this number 5 is what? The connector, while this number 4 is the emitter. Number 5 here is the first signal, while number 4 is the second signal. While this number 6 is the base that controls the light sensors here. Once this one has collected the voltage or the current from the source, now this one will be connected to ground to neutralize if there is an excessive voltage. After it might have finished its own job, it will transfer. This arrow means the transferring of signal to light sensors. This light sensor, this base now will be connected to ground, just as I explained before. It will be controlling these two signals. It will be controlling these two the signal to balance the voltage. That is what it does here. Now, in this pin 4, I have already explained it, but I'm repeating it once again. If you don't understand it initially from the first one, you can understand it now. This pin 4, the same thing is applied. This pin 1, we collect the voltage. This cathode is the same thing. It will be connected to ground, while this number 4 here will be connector. It will be connected to ground as well, while the pin 3 is the emitter, being the output. Once this one might have finished the job, it will transfer the signal back to these light sensors, and light sensor might have finished, it will transfer it to electrical signal. That is how they function. I've already explained this before. Now, often the pin is used to connect with ground or negative using a high value resistor. In this configuration, force triggering due to noise or electrical transient can be controlled effectively. Just what I explained before. That is the work of the base, being the pin 6. And in the other aspect that has 4 pins, the work of it is the pin 4, being the pin 4 being the connector, which it controls if there is an excessive voltage. In terms of pin 6, the pin 6 being the base will also control. Those are the two areas that does the job. They do the job effectively. Now, description is the same thing as in series. In photo-transistor optocoupler, these are the series. These are the series. It has PC816, PC817, TLV817, K847PH. They are all these are the few series that I know, and all these are working under DC related isolation, DC circuit. They are all used in DC circuit. So in case if you are to purchase optocoupler, from what I showed you here, you can differentiate it. You can differentiate phototransistor from photo-darlington. Now, this is the optocoupler pins 4 and 6. Now, let me explain a little bit of this. This number that you are seeing here is called device number. This one that you are seeing here is called device number. You can differentiate it. This one is for photo-darlington, while this one is for photo-transistor optocouplers. 6 leg, 4 leg. You can also see this one in 4 leg. You can also see this one in 6 leg, all depending on what you are about to do. Now, I want to use this F. It could be N. It could be depending on the company. This F stands for logo. This F stands for logo. While this 4N33 stands for device number. And 4 legs here, you can see here is 816. It stands for device number. While this Q here, this Q that you are seeing here, it could be Q, it can also be K, it can also be L, it can also be any number, all depending. It stands for assembly package code. That is what they stand here, assembly package code. Here now we have L. L stand for assembly package code. So this is all I have to explain for now in terms of this. Remember, I use the diagram or the internal structure of four leg or six leg or six pin to explain how it functions. So from there, you can be able to understand how this how this optocoupler 4 pins and 6 pin, how they work. Now, this is the application of optocoupler in terms of four pins and 6 pins. They are applied in low power logic circuits, telecommunications equipment, portable electronics, solid state relays, interfacing coupling systems of different potentials and impedances, power supply regulators, digital logic input, microprocessor input. These are the application aspects of auto coupler or auto isolator, 6 leg or 4 leg. Thank you for watching my video. See you in the next class.